Okay, the next type of sequence that we are looking at is geometric sequences. So geometric sequences, this particular sequence here is a geometric sequence, and so on. Another geometric sequence might be one like this. And so on. And now another one, easier one, again, might be something like this. And so on. Of course, we could have a geometric sequence that actually goes something like this. The next term after that, you can figure that one out yourselves. And of course, also geometric sequence may go something like this one here, for example. Say 8. And so on. So all of those are geometric sequences, and hopefully you have figured out by now that to get a sequence you need to multiply, so the term is multiplied by a common ratio to get the next term. Alright, so if for example like this, for example, for 2, 1.5, etc. Yeah, you might think, okay, we're dividing by 2, but we actually need to look in terms of multiplying, so we're multiplying by a half. The one that went 3, negative 9, 27, and so on, we were multiplying by negative 3. Okay, so we're talking about multiplying, so, and in this it's termed the common ratio. So our arithmetic, we were adding, this time we are multiplying each term by some particular factor. So if we're going to represent that, so we can represent this by, again, if we're looking at A being the first term, and this time instead of having a difference, we've got R is the common ratio, then our terms become A times the ratio squared, cubed, and so on. So that's ARn minus 1. Just squeeze it in on the end there. Okay, so that of course is term 1, term 2, term 3, term 4, and so on, term n. So from that you can deduce that term n equals A, our common ratio, A times our first number, times the common ratio to the power of n minus 1. Okay, because all of these term numbers were all 1 less than the power on that common ratio. Or 1 more than, I should say, not 1 less than. Alright, so our common ratio to find that was just term n plus 1 over term n. So any term divided by the previous term. Okay, so if we have, say, 3 geometric sequence, and this geometric sequence, this goes x, y, z, and so on. Then the middle term here, this y, would be what we would term the geometric mean. And for the geometric sequence, that geometric mean turns out that y squared equals x times z to find our geometric mean. Okay, so there's more in your textbook on this, page 195 and 196, if you want to have a look a bit more in a bit more detail. Right, so let's get on to some questions. Alright, so first question, state whether the sequence is geometric. By finding the ratio. And so here's our sequence, term n in the sequence, 2, 6, 18 and so on. If geometric, find T4 and Tn. Alright, so when we have a look at this, when we go from there to there, you can get there by times and by 3. When we go from here to here, we can get that by times and by 3 also. So the sequence then is geometric. So it is geometric. A is 2 and R is 3. So therefore, term 4, well, we can get that by saying 2 times 3 to the 3. And so that would be 54. Okay, so term n then, in general, is 2 times 3 to the n minus 1. Okay, simple. Next question. Okay, so let's find the nth and 10th terms in the geometric sequence. Where term 1 equals 3 and term 3 equals 12. Alright, so term 1, that's equal to A, that's equal to 3. And term 3, that's equal to AR squared, and that's equal to 12. Now, from the first one here, we know that A is 3, so we can rewrite that and say that's 3R squared equals 12. divided by 3, so r squared equals 4. So when we take the square root, r equals plus or minus 2. Now, the question is, which one is it? Is it plus 2 or is it minus 2? And the answer to that question is, we don't know. Because term 3, which is 3 times r squared, and if we put in the negative plus 2 and the minus 2, we get 12 both times. So we would actually need to know the second term for us to be able to know whether it's the positive 2 or the negative 2. So in this case we have to take both. Okay, so it says find the nth terms. Well, the nth term then is either 3 times 2 to the n minus 1, or it is 3 times negative 2 to the n minus 1. And as I said before, we don't know which one it is because we haven't got enough information to tell us. Okay, so term 10 then would be a, which is 3, times 2 to the 9, or term 10 is 3 times negative 2 to the 9, and we put that in our calculator, we get 1536. For that one, a negative 1536 for that one. Okay, right, let's have a look at another example. So, I'm going to kind of paraphrase this. Term 5 is 14, and term 7 equals 0.56 of a geometric sequence. Find R, A and Tn. Okay, so let's write down what we know, because we know term n equals AR to the n minus 1. So term 5 is 14, is AR to the 4. Term 7 equals 0.56, and that equals AR to the 6. Alright, so we've got two equations, equation number 1 and equation number 2, and we need to solve them simultaneously. Okay, and so a couple of different ways we can do that. So we can do it by hand, so I'll go through it doing it by hand. So if we do it by hand and we do number 2 divided by number 1, then we get 0.56 over 14 equaling AR to 6, AR to 4, the A's cancel. We've got R squared, so we have R squared equals 0.04, and so R has got to be plus or minus the square root of that, which is 0.02. So again, we have two options. Which one is it? Again, we don't know, because we've got term 5 here and term 7 there. So we don't actually know, because term 5 and term 7 give us even powers, and so even powers for negatives are always going to be positive, and of course even powers of positive numbers are going to be positive as well. So we don't have enough information, so again we've got to work with two different sequences in there. So let's have a look then. If, so for R equals 0.02, and I'm going to sub into 1, okay, and equation number 1 was the 14 equals A times 0.02 to the 4, and out of that we get that A equals 8,750. So from that we can say that term N equals 8,750 times 0.2 to the n minus 1. Alright, and so for R equals negative 0.02, and if you substitute into 1 again, you get 14 equals A times negative 0.02 to the power of 4, and from that you get A equals 8,750. So no surprise that they are A's both the same, so they certainly should be. But this time the sequence is slightly different. Because this sequence will go positive, negative, positive, negative, whereas this one up here, they're all positive numbers. Okay, so, alright, so that's how we can do that. We can solve that by doing that. You can by hand, but you can also solve using the simultaneous equation. Alright, so in solving the simultaneous equation, I suppose you call it a template on your calculator. So where we find that on our calculator is we find that from our main screen. We need our keyboard on, and then we're looking at the 2D, and in the 2D it's the bottom row, third from left. Okay, so it's the third from the left. It looks like this. Right, that's how it looks. So that's the template, and the way you would fill this template in is you would have it look like you put 14 equals A to the 4 up there, and 0.56 equals A to the 6. Then next to that you have A comma R before you press execute. Now to get out things like that, you go to the ABC tab. Go to the ABC tab, and then you can use any you like. Okay, so you press execute, and then that gives you the answer. Alright, so that's it. Hopefully that makes some sense. So you're up to now exercise 6D, which is set number 4 on your sheet.